Okay, this should really, as I think about it, be called rotating. Because you've all, well, let me pause it while you get your lunch. Well, it's not better, like or better, but to revolve, like the planet Earth revolves around the sun in a big circle or elliptical orbit, and the planet Earth rotates on its axis. So really, we're rotating here. And yeah, so I guess it's a misnomer, right? When you go through a revolving door, it really revolves, does it? It's just kind of like your lockers out there, or a padlock they call it a combination lock. It's not a combination, it's a permutation. It's misnamed as well.
I don't know what you're talking about.
Well, a combination, no, good grief, hang on. I'm going to pause the video. So we're talking about revolving or rotating figures around, right? You got to think of it going very, very fast, right? And if you spin it up fast enough, anybody ever use, say, a wood blade? A piece of wood spins really quick, and you put a blade in it, right? And as it spins, your eyes kind of see a different shape than, you know, maybe the 2x4 you have on there. It really starts to look like a what?
Like the little place you press the button and the little ring runs around?
Sure. Yeah.
Like a door handle. Shake that around and it looks like there's a tool.
Oh, well, we're getting somewhere. Yeah. All right, let's take this, which probably should be called a rotating door, right? And if we spin it really fast, it might start to take on a three-dimensional shape. What would that shape be?
Cylinder.
A cylinder, right? You got to picture it rotating. And like, when you guys get into calculus, that'll be kind of a big thing. It'll be a little more complicated, right? But you'll form certain figures from a graph of a two-dimensional function, and you'll rotate it around, say, the y-axis very quickly, you know, and you get a vase or something, right? And you'll do some calculus calculations on it. And that's all very fun, okay? Oh, by the way, here's some, you might see something like this when you get to calculus, some of you like that, right? Three-dimensional figures comes from a two-dimensional figure being rotated very quickly around an axis, okay? So let's just see if we can sketch out what these would be if we rotated them around. Before we do it, what do you think that rectangle would end up being if we rotated it around? Cylinder, right? So you can kind of think of it like a reflection, right? To start out, so we just draw its reflection on the other side as best we can. Like that, kind of, right? Well, not quite perfect, but, and then just like that. You end up with a cylinder. All right. The next one might be a little trickier to sketch in there. Let's see if we can draw the reflection of this thing freehand. What is all that ruckus outside? I'm not doing a great job. So that'll go like that, right? And like around here, and then down here, like that, sort of. And this guy on the inside of it. I don't know. And I'm not the greatest at this. I don't know if I can kind of make out what I got here. As good as I can get. What would you say that is? It's kind of generally looks like a cylinder, right? But with recesses in the top and the bottom, right? So we'll call this first one a cylinder. And this looks like a cylinder with recesses top and bottom. I don't know. Well, the idea is you just get to thinking about spinning it very quickly around. Third one shouldn't be quite as difficult. Well, not if you want your pyramid to stand up. I don't know about a cone. Looks like two cones, maybe.
A sphere.
No, not a sphere. I would say it looks like two cones. Or does it maybe look like a toy that you maybe have?
Height.
You know, at the top? until you spin it on the floor of the table, and it stands up
Like a
while it's
big wave.
spinning, because it has angular momentum, it's called. Well, I should show you that physics video of that. It doesn't fall over. One way to think of it is because like whatever way it tips, like if the weight goes to one side of the axis or the other, it's spinning so quickly it averages out that weight, and so it keeps it from all going over all the way. Anyway, so you might call it a top, like a little kid's toy, a top, something like that. Okay. None of these are really important, except for the fact that you're getting a kind of picture in your head what's going on here. And that's really all there is to that part, right? That's the description of it. Now, your problem set will just be these regions questions here, okay? Now, yeah, we'll make them due tomorrow, okay? Now, for some of these, you are going to want to draw a sketch, okay? And there will be some other things that we have to bring in after you make your sketch of the 3D object, like maybe they want the volume of the thing, right? Or maybe they're asking you to rotate it about the short side of a rectangle. You know, what's the radius of it? That kind of thing. So you'll have to think about the things you learned once you get the three-dimensional figure worked out in your head or sketched out, okay?
What's a median?
A median?
Yeah.
Well, we cut median of a what? A triangle? What number you want? Okay, who remembers where the triangle median is? So if you have a triangle, the median goes from a vertex of the triangle to the midpoint of the other side.
I can't even rotating motion.
Okay. Well, let me ask you this. If you rotate something, will you get a pyramid, something with flat sides?
Yeah.
No. No, Charlie.
It's
Yeah, okay. But anyway, you get the idea. Struggle through this as best you can. Work on this for the time being in class, okay?
Are we gonna turn the tenor?
Tomorrow, this is one we'll go in the morning. I'll put the answers up and we'll go over it tomorrow, okay? So, your problem set. This is simple. I told you this was a short one, right? Your problem set is all problems. They're all the Regis problems. Okay?